Welcome students. Myself Ahirrao VA from Department of Instrumentation and Control Engineering. मराठा विद्याप्रसारक समाजास कर्मवीर ॲडव्होकेट बाबूराव गणपतराव ठाकरे कॉलेज ऑफ इंजिनिअरिंग नाशिक. Objective: to learn the concept of grounding. Outcome: students will be able to understand the importance of grounding in system designing. First, we will just go for what are the different grounding types. First is the equipment ground. Then next is a static ground. If you are having any system which may consist of different components, a common ground to the whole system is called as a system ground. For maintenance purpose, you may temporarily have the maintenance ground. Usually in electronic circuit, we are finding the electronic ground. And the last one is the lightning ground. Few ground definitions we should go for. In general, a ground is said to be an equipotential reference surface. But when we will use in relation with the electromagnetic compatibility, a ground is nothing but low effective impedance path for the return. The ground terminology for electrostatic discharge is a different one. So ESD ground is a surface that can source or sink large amount of charge without changing its potential. And the last one is the safety ground. It is a conductor which will provide a path for the currents to flow during a circuit fault, which normally we are calling as a short circuit. Then grounding plays important role for first the design of electronic systems and PCBs. Second, installation of instrumentation panels. And third, installation of analog as well as the digital systems. There are few grounding categories. The first is the safety ground, which we are calling at the earth potential. So it is a permanent and continuous low impedance path. The second category used is known as the signal grounds. Signal grounds may or may not be at the earth potential. Signal ground is a ground connected to earth through low impedance path, that is called as a earth ground, and that is a path for dangerous leakage currents and the short circuits. Safety ground, for this one, as we have learned, it is a permanent, a continuous one and low impedance conducting path. For this one, first consider the situation of an equipment which is having some circuitry, and at some point the potential is say V1 and it is connected to the chassis via the stray impedance Z1. Similarly, Z2 is the stray impedance between the chassis and the ground. So if the voltage V1 is considerably high in magnitude, Then, by the potential divider rule, the chassis will be considered at a potential of Z2 upon Z1 plus Z2 into V1. Many a times, the chassis will be at nearly equal to the potential V1. Another most common situation whenever we are having a supply through a fuse line into the chassis, or that wire is just giving the supply inside the chassis, and if there is a situation of insulation breakdown, then dangerously the chassis potential will be nearly equal to the voltage applied from external side, and that will cause the shock hazard. Here we will discuss about the signal grounds. So signal ground is the equipotential point or a plane which will serve as a reference potential. Normally, all the practical grounds are not at equipotential. The difference in potential between two physically separated points will cause some false currents to flow in a reverse direction into the circuit. But overall, a signal ground is a low impedance path for the current to return to the source. There are a few factors which are important while selecting the proper ground system. The first is the type of circuitry, means whether it is the analog or digital circuitry. Then what is the operating frequency? What is the size of the system? What will be the effective impedance path? The current amplitude, the noise voltage threshold, and some other constraints like safety. We will now go for the different types of signal grounds. The first is the single point ground system. Second is multi-point ground system. And the third is hybrid ground system. Now let's learn one by one. First, the single point ground. There are two types, that is the series connection and parallel connection. Series connection is also called as to be having the common ground or the daisy chain, and in case of parallel connection there is a separate ground for each of the circuit. First look into the series connection. So if we will have, suppose, three circuits, and these three circuits are connected to the single point ground and they are connected in series. So in the diagram, Z1, Z2 and Z3 are the ground conductor impedances for the circuits 1, 2 and 3 respectively. The currents for circuit 3, the ground current is I3, but as there is a series connection for circuit 2, the current will be I2 plus I3, and for circuit 1 the total current will become I1 plus I2 plus I3. The different currents as resulted by the series connection in a single point grounding system will cause the different potentials generated, and those are VA is equal to I1 plus I2 plus I3 into Z1, VB equal to I2 plus I3 into Z2 plus VA, and VC will be equal to I3 into Z3 plus VB. And because of this one, the potentials at the three junctions will be different, and if any of the potential will be higher to that of the potential of any of the circuit operating, then a reverse flow of current may take place. The series connection should not be used between the circuits operating at wider power levels, and here one precaution we have to take: the most critical stage or sensitive to currents should be nearest to the primary ground point. Then the next connection is parallel one. So as per the circuit diagram, the three circuits are connected to the single point ground, but each circuit is having its own impedance, and whatever ground currents flowing, they will not interrupt each other. The parallel connection is most desirable at low frequencies, as we know that impedances increases with frequency, and at very high frequency the ground impedances may act as antennas and may radiate the noise to the nearby circuits. The second type is the multi-point ground. As per the name multi-point, so every circuit will have the separate but the lowest impedance ground connection. Usually, multi-point ground is used at high frequencies greater than 10 MHz and in digital circuits to minimize the ground impedances. So for each of the circuit as shown in the diagram, the shortest path is selected to the common ground. As each circuit is connected to the common ground at different point, that's why the name is multi-point ground system. Many system ground problems occurs as a result of common impedance coupling. Means between two circuits, the ground impedance will act as a common impedance, and because of that one, the ground problem occur. The different conditions like high impedance ground, which is having the large inductor value, then if there is large ground currents, there is a possibility of magnetic pickup by the nearby ground conductors. Usually very sensitive circuit is connected to the ground, and at high frequency in the single point grounding system, the parasitic capacitances may get closed to form the ground loop. For this reason, in some of the circuits, the single point grounding system may work satisfactorily, and in some, the multi-point ground system may work faithfully. But if there is the condition of variation in the operating frequencies, then the third type of ground, that is the hybrid ground, is preferred. As shown in the circuit, the three different circuits which are connected through the capacitances to the common ground, and also a single conductor will run up into a single point, and that's why, as it looks like a combination of single point as well as multi-point, the name is hybrid ground. Whenever we are going to use the capacitors, then at low frequency, the capacitive impedances will be very high, and that's why the grounding connection will act as a single point ground. But when the circuit is operating at high frequency, then the impedances of the capacitors will be low as compared to the separate ground conductor which is connected to a single point, and that's why this circuit will act as a multi-point ground. In case of some of the applications, hybrid ground of this type is preferred. Another variation will be capacitances replaced by the inductances, but this circuit is not mostly preferred. At low frequency, it will act as a multi-point ground system because the inductors are offering very low impedance as compared to the common ground conductor path, and at high frequency it will act as a single point ground because the inductive impedances will be greater at high frequencies. Reference: to study the grounding system, you may refer the book titled Noise Reduction Techniques in Electronic Systems by Henry W. Ott. Thank you.